Hey kids, this week is the moon. The moon is Earth's largest natural satellite. It's the only moon the Earth has. It's really big for a moon, for a rocky planet to have a moon that large. Like if you look at Mars, the two moons around Mars, Phobos and Deimos, they're just not very big. They're little bitty asteroids that got caught in Mars gravity as they went past, and they started going around and around. The moon, if it had tried to go past the Earth, it would have been way too big for the Earth to capture. And so there's several theories for how moons are made. And the capture theory, that's Jupiter, Saturn, they capture moons all the time. That's why they're up in the 60s and 70 moons. Like, it's ridiculous how many moons they have captured as they tried to travel past. And of course, Jupiter has the biggest moon in the solar system, named Ganymede. Jupiter can just grab something that could have been its own planet and just pull it into orbit. And so it's pretty amazing. But the Earth, not so much. The Earth is not that big. But we'll talk about the different ways the Earth's moon could have happened in just a minute. So the moon, normally this week I would have rocks from the moon in a little glass case to show you guys. You're not allowed to open the glass case, but you can pass the glass case around the classroom. And it's really cool to have, it's just they're about this big, little moon rocks to pass around the room. And then of course I have a big rock made of the exact same chemical material as the moon rock. They're called anorthosites. And we could have passed that one around the room so you could like feel what the moon rock feels like, even though the rock you're holding is from the Earth. And then you pass around the glass case. But we can't do that. That's unfortunate. NASA can't check out moon rocks to me if I don't have a class to show them to. There's lots of rules about borrowing national treasures, like moon rocks, for example. Anorthosite's not the only kind of moon rock up there. Anorthosite is the light part of the moon, the highlands, the part of the moon that's light colored. The dark part of the moon, that's all volcanic rock, because the moon had lava flowing on the surface for a while. It was really hot for a time. And those are basalts, exactly like the basalts at the bottom of the Atlantic Ocean, where the Atlantic Ocean splits open and the magma comes up, mid-ocean ridge, all that. Basalts are being made there every day. Well, these basalts are exactly the same volcanic material, same silicate content as the bottom of the ocean, of the Atlantic. So anyway, y'all don't want me talking about rocks. You know how much, I could spend 6 days talking about rocks, and you guys would turn the video off right about now. And anyway, I'll move on to something a little less rocky. So the moon's theories for how the moon's capture theory is the first theory about how the moon got around the Earth. But if the moon was as big as it is, comes around, it's big enough to have 1/6 Earth's gravity. That's a lot of mass. There's a really massive object. The moon is not a small moon. It's pretty big. And so this big object going past the Earth, and the Earth has to be strong enough to like pull it into orbit. But what would have happened if the math had been just right, if the velocity had been just right, if the direction had been just right, if the distance had been just right? What would have happened is the Earth and the moon would have kind of swirled around each other, and that's not what's going on. Those are some simple words. I should be able to say simple words. That's not what's going on. That's what's going on with Pluto. Pluto, when it tried to capture its biggest moon, Pluto has more than one, but when it tried to capture its biggest moon goes by, and Pluto gets pulled towards it, and it gets pulled towards Pluto, but they missed. And now they swirl around each other. So Pluto doesn't just go around the sun. Pluto swirls around its moon, and they go around the sun as a pair of co-orbiting objects. The center of gravity between them, the center of mass between them, and their rotational center of their orbit is actually in between the moon and Pluto. But the Earth's moon doesn't do that. That's not how Earth's moon works. Earth's moon is more of a normal moon. It goes around the Earth, and the Earth doesn't get all wobbly in its orbit, not very much, just a little tiny bit, because the Earth's moon, but it is a very large moon. So capture theory, not mathematically very likely, but it's one of the theories. And so the moon was going by, and the Earth said, nope, you're going to stick around here, and made it orbit. It's not likely. Secondary theory, accretion. So you've got the accretion disk. I'm going to put an accretion disk right over there. I'm going to put an accretion disk up. An accretion disk is flat disk of matter that is swirling around the sun, making these rings, and each ring turned into 1 or 2 planets, and the moons around those planets. And so material that should have fallen into the Earth instead stayed in orbit and eventually swirled around the Earth enough to clump up into one ball and make a sphere the size of the moon. It's possible. It's one of the better theories, but that would have been a lot of material, and most of it would have been absorbed by the Earth. And so there's a few flaws with the math. There's a few flaws with the amount of mass. It doesn't quite work as well as the next theory. The next theory is the one that works the best mathematically and works the best if you look at the geology of the moon, and works the best if you look at the geology of the Earth. And y'all don't want me to talk about rocks again, but the rocks are the proof of how the moon formed. And so I'm going to talk a little bit more about rocks, just a little bit. I'll make it quick. And so the accretion theory, that the Earth formed and the moon formed at the same time from the same accretion disk, from the same ring, from the same planetary ring orbiting the sun, is possible, and it's not bad. But there's a couple of problems with the amount of mass. The moon should be a lot smaller if that were the right theory. And then theory number 3, the most widely accepted one so far, and the coolest by far. This is just the coolest thing. The Earth is going around the sun, and Theia, another planet, is going around the sun, and they're in the same orbit. They're sharing an orbit because the accretion disk that made the Earth on the opposite side of the sun, the accretion disk also made Theia, and is going around the sun, and Theia caught up to the Earth. And Theia is about the size of Mars. Theia is a pretty big, it's a good sized planet. I mean, Mars isn't a big planet. It's not as big as the Earth. But it's a good sized planet. I mean, it's a full sized planet. And this full sized planet catches up to the Earth and slams into it, and rocks explode in all directions, and Theia and the Earth start spinning together and turn molten again. The Earth had finally formed a solid crust. Theia ruined it all. Turned everything molten again, melted the surface of the Earth, lots of lava everywhere, and then part of Theia melted into the Earth, and part of Theia exploded out away from the Earth, and the part that exploded out away from the Earth turned into the moon. There could have been one big chunk. There could have been millions of tiny chunks. There could have been billions of tiny chunks. There could have been 6 big chunks. All of it got together somehow and made the moon. This is the collision theory of moon formation, and it's probably the most, mathematically, probably the most well supported. And with the physical evidence, the types of rocks on the Earth and the moon, the types of oxygen isotopes on the Earth and the moon, they match. So those materials were probably close together at some point in time. On the Earth you have anorthosites. On the moon you have anorthosites. On the Earth you have basalts. On the moon you have basalts. On the Earth you have brachias. On the moon you have brachias. They're different types of rocks. I'm going to stop talking about rocks now, but rocks are the best evidence we've got. And then there are also rocks on the moon. I'm not going to stop talking about rocks yet. There are rocks on the moon that formed in orbit around the moon from molten materials, so they formed little marbles, and they formed olivine, which is one of the rocks you can find on the Earth. Olivine is a green rock. So the moon has green marbles about like that all over it because it was molten lava after this collision. Molten lava just forms perfect little droplets, little round rocks, and they fell onto the moon and the Earth, a few of them. And you get these cool little olivine marbles. Unfortunately, NASA doesn't loan out the olivine because they only brought back a couple because they weren't interesting enough to study. They're just really cool looking. Anyway, so the moon capture theory, not great. The moon accretion theory, not as bad, but still the math is just still not quite where we need it to be. And the collision theory, definitely a possibility, definitely one that scientists like. And so the moon has all these, the moon is fascinating. There's all these amazing features on the moon. The highlands, light-colored anorthosites. Lowlands, dark-colored basalts. And anywhere you have a massive impact. There's a crater, and the crater, there's the rim, there's the floor, there's the little mountain in the middle where the impact object popped back up from it, pressed down, and it pops back up a little bit, and then objects that shoot out from there form these lines called rays, and breccia, which is all the rocks broken into little pieces and then combined together and then turned back into a rock and just scattered everywhere. So breccia is a type of rock where you have broken rocks sealed together by cementing. Y'all remember the process of cementing, and then those rocks, so it's got breccias all over the place. If you look at, I have a model of the moon, which is, it's a globe, and it has all the names of all the mountains and all the craters. Every crater has a name, every mountain has a name, all named after famous people or astronomers that studied those things. I want you guys to have the globe to look at, but we can't do that. It's just not going to happen. So anyway, the moon, really amazing stuff. The only object not on the Earth that humans have walked on. And so the United States, Israel, I can't remember all the other places that have walked on the moon. I mean, I'm pretty sure Japan and Russia, I know Russia. I'm pretty sure Japan has probably had somebody walk on the moon. If you look at the moon launch rockets, the Atlas V, the Saturn V, the big, the Saturn V is the rocket, the Atlas is the engine on the rocket, is biggest rocket ever made, most powerful rocket ever made, except the Russians made one that was 1 foot taller because they needed to. It had to be 1 foot taller than the US. That was in the design specs, must be taller than the Saturn V. It was in the Cold War, did some strange things, but it got us to the moon. And so, but then you look at the Japanese rockets and they're little bitty, I swear to you, they are the most efficient, smallest rockets ever launched. You got to take a look at some of the rockets out there. I'm gonna cut this short in a second here because I'm running out of time. And then you have the most sophisticated, amazing rocket systems ever made. Elon Musk, SpaceX, the guy that invented Tesla. Watch the Heavy Falcon launch videos on YouTube. Very cool. The rocket launches he launched his Tesla into orbit around the sun, not around the Earth, because he wants his Tesla, his personal car, orbiting the sun in case aliens ever discover our planet. And they go, oh look, somebody launched a car around orbit around the sun. His rocket launched, deployed its cargo. The rockets that fall off in mid-flight went back to the launch pad and landed on the launch pad. They're amazing technology. He doesn't waste rocket bodies. They go up, the rocket leaves, the things fall off, they go back home. It's an amazing Heavy Falcon rocket launch, SpaceX. Google it, it's on YouTube, it's a really good video. That should be good for today.